All right, in this video, we're going to do contrast. Before, with post hocs, we're looking at comparing every group with every other group. With contrast, we're being a little bit more specific, more targeted. So contrasts are used to, a lot of times, with like experimental studies, we'd use them to make more specific comparisons between one group and the other, or a couple of groups with another. We have a couple of ways we can do this, as usual with SPSS. This is the same data set, the simulated data set that we've been using. The options that we have are generally, if we're thinking about maybe combining groups like A and B or C and D, or if we want the treatment effects, we can look at each of the groups from the grand mean, the mean of the whole group. But to do that, we have to give up one of the groups to allow that to work. So I'm going to show you where that's at. In general linear model, univariate, this is one place where this is the first place we're going to do it. Pretty easy. Like with all of these dependent value, the value goes in dependent and the group goes into fixed factors. This is the window we'll use for two-way, so there's more options here. And we want to look at contrasts. Now I have one in here already. Yours might show nothing because nothing's set. And these are our options for contrasts. I'm going to show you deviation and simple. Deviation first, and then our reference category. They give us the options for the first group, so A, or the last group, D. We know that D is pretty different from everything else. So I'm going to keep our reference group as D. And we hit continue. Everything's set and plots. We don't need right now. We don't need to run our post hocs because we've done that. And we don't need EM means. And we don't want any of that right now. We're assuming we've already checked all our assumptions. And we click OK. Bring this over here. We see there's our groups. And down here are our contrast results. So you can see that the omitted is category 4, which is our D. And this is level 1, which would be A, B, and C, versus the grand mean, and so -5. So this right here, this contrast estimate, that's our treatment effect that we put in our model. Right there, -3, -5, -5. But the last category is omitted, so we can't see that. We're using that as an observation, so it doesn't get included. We have to use it for the comparison. This is for comparing the grand means. Now if we come up and go to analyze again, and let's change that contrast from deviation to just simple contrast. And I'm going to keep the reference again as the last. So now in this one's a little bit more interesting because now our reference category, D, is being compared against all of these. And so you can see how different these means are. So A, difference from D, B, difference from D, C, difference from D. And we have some of this with post hoc, but we're using these contrasts and we're specifying them more specifically to give us a little bit more of a nuanced explanation, and it allows us to kind of get a more targeted analysis without losing power and without adding kind of influence or noise. So now if we want to get more specific, this is going to get a little bit more specific. Say we wanted to combine groups or look at more general areas. I'm going to generate the error bar plot. We've done this multiple times now. As a reminder, we can see A, B, and C. B is significantly different from A. We saw that at like 0.01, so it's just barely there. But A, B, and C are very clearly altogether pretty similar. A and C are almost identical. So let's look and see, let's compare A and C with B and D. To do that, we're going to go a little bit different. Before we went to general linear model and univariate, for this we're going to go back to our compare means. This is just for one way ANOVA. Again, value independent factor. up here with contrasts. And I have these left over, so I'm going to remove these for now. Now, as I add these, pay attention to the coefficient total. What we're going to do, assuming A, B, C, and D, we're going to add either a 1 or a -1 to specify membership. So if we want to do A and C versus B and D, we're going to put 1 for A, -1 for B, 1 for C, and -1 for D. You see that coefficient total should be 0. If it's not, the test will run, but your results are not going to be, they're not going to make sense. And we'll leave our effect sizes here. Polynomial we don't want. So click continue. And we're not doing our post hocs right now. We don't need any other options. Click OK. All right. So here again, this is our omnibus test. We already know that's significant. Our effect sizes. And here we can see what our contrasts were. So A and C together with 1, -1, -1, and B for B and D. And we are assuming that we didn't generate this time, but we already know. We checked our assumptions that we are assuming equal variance. So we're going to look at this top row here. And we see that there is a significant difference. Pretty significant. Confidence interval -2.3 to -1.9. That's pretty good. So for sure to say A and C are significantly different than B and D. Now, that difference could be D because D is very different from the rest. We could also try a couple others. Let's go back to our compare means, one-way ANOVA. Look at our contrast again. Now let's change this to 1. You see our coefficient total is now 2, so we can't do that. That doesn't work. So if we wanted to look at A and B and then C and D, coefficient is 0. Now we're going to look at A and B versus C and D. Still pretty significantly different. So probably that D is what's pulling that up. Yeah, look at another one. Compare means, one-way ANOVA, contrast. And what if we did make this one 1, so maybe C is 1, and we're going to change A to -1. Again, coefficient is 0. Click continue one more time. Very different. So that is all probably D pulling that up. But those are our contrasts. That allows us a little bit more flexibility, particularly useful with experimental designs when we have more specific comparisons of interest, like testing the effects of different treatment conditions or examining specific groups' differences based on our hypotheses. Maybe we have a specific hypothesis about a control group, or depends on our experimental design. But the contrasts overall provide a more powerful tool for testing hypotheses in ANOVA by just allowing us to do more specific comparisons than comparing every group to every group while maintaining power. So those are contrasts.